We have covered orbits, apertures, link budgets, handsets, and spectrum. One piece is left: how all of it fits together. Because a direct-to-device system is not a satellite talking to a phone. It is an end-to-end mobile network that happens to route part of itself through space. Every session traverses several elements before it reaches anywhere useful. The handset reaches the satellite over the service link. The satellite reaches a ground gateway over the feeder link. The gateway hands traffic to the operator's core network, and from there to the internet or the telephone network. Notice where the intelligence lives. The satellite provides radio access, but authentication, mobility management, subscriber databases, billing and quality of service all stay on Earth, in the core the operator already runs. That split between service link and feeder link is one of the most useful distinctions in satellite communications. The service link is the hard one. It has to work with a battery-powered smartphone pushing a few hundred milliwatts through a compact antenna. The feeder link has none of those constraints: large parabolic antennas, high transmit power, wide bandwidth, so it typically runs at much higher frequencies, Ku or Ka band, carrying enormous capacity between the spacecraft and the ground. The gateway is the bridge, and users never see it. Inside, you will find large tracking parabolic antennas, high-power RF equipment, satellite modems, fiber connectivity, LTE, or 5G networking equipment, and precise timing and synchronization. Because it has big antennas and effectively unlimited power, it can absorb losses no handheld device could, which is the pattern of this whole course. Almost all the complexity removed from the smartphone reappears inside the gateway. Now, how much does the satellite itself actually do? The simplest architecture is transparent, sometimes called bent pipe. The satellite receives the signal, translates its frequency, amplifies it, and forwards it to the gateway. Almost all the cellular processing happens on the ground. The alternative is regenerative. Here, the spacecraft does part of the radio processing itself: demodulation, decoding, scheduling, sometimes portions of the LTE or 5G protocol stack. That can cut latency, reduce feeder link traffic, and allow more autonomous operation. But it is a trade, not an upgrade. Regenerative payloads move complexity from the gateway into the spacecraft. More onboard processing, more power draw, more software, more cost, and harder updates once it is in orbit. Transparent payloads keep the satellite cheap and simple, at the price of leaning heavily on the feeder link and on gateway complexity. Neither one is universally superior. The reason all of this works commercially is integration. To the mobile core, a satellite looks like just another radio access network. Subscribers authenticate with the same SIM or eSIM procedures. Mobility follows standard 3GPP mechanisms. Voice still runs through IMS billing. Roaming and quality of service policies carry on unchanged. So an operator extends coverage into remote territory while preserving virtually all of the infrastructure it already owns, which leaves the architectural choice. Some operators maximize satellite simplicity and push processing into gateways. Others add onboard intelligence to depend less on ground infrastructure. Some build nationwide partnerships with mobile operators. Others pursue global satellite-first architectures. Every one of them is solving the same problem: connecting an ordinary smartphone to a conventional mobile network through a fast-moving satellite. The architecture just decides where the complexity sits. To close, a D2D satellite is not an isolated communication system. It is one component of a cellular network that runs from the handset all the way to the operator's core. Gateway design, feeder links, onboard processing, and 5G integration all decide where the complexity lives. And these systems succeed not because satellites replace terrestrial networks, but because they seamlessly become part of them.